Okay, the next thing we're going to look at now that we have some experience with radical expressions is radical equations. So as you can see here by definition, a radical equation is any equation that has a variable under a radical. So if I just look at these first four, just determining yes or no, are they radical equations? I noticed that on the first one, because I have an equal sign and because I have a variable under a radical, the answer to that would be yes. On the second one, I notice I have an equal sign, so it is an equation. I don't see a radical, so my first thought might be that no, this is not a radical expression. But if I change this from exponential form, wouldn't this be the same thing as the cube root of x minus 2 squared equal to 25? Once I change it to this, I see that I still have that equal sign, and now I do have a radical with a variable underneath it. So yes, this will be a radical equation. Looking at number 3, using the same concepts, I say I do have an equal sign. I do have a radical, but a radical equation has to have a variable under a radical. Since I have a number under a radical, this would not be a radical equation. And then on number 4, I notice that I don't even have an equal sign, so this would be a radical expression, not a radical equation. So how do I solve radical equations? Well, what I want to do is I want to start by isolating the radical, and then I'll raise both sides of the equation to the same power in order to get rid of that radical. So it's kind of similar to when we looked at absolute value equations before, where before when we talked about absolute value equations, we talked about how we had to isolate those first as well. So let's go through a couple examples on this. So if I look at example 1, I have the square root of 5x plus 1 minus 6 equals 0. It is a radical equation. I have an equal sign and I have a variable under my radical. So if I want to isolate the radical equation, that means get the radical equation by itself, or the radical part by itself, excuse me. So I'm going to add 6 to both sides, giving me the square root of 5x plus 1 equals 6. From here, I want to raise both sides of the equation to some power. I choose my power based on what it's going to take to get rid of my radical. Well, since this is a square root, which technically has an index of 2, in order to get rid of a square root, I will square it. I square both sides. We'll notice that my radical and my square cancel each other out. So they cancel on the left, giving me 5x plus 1 equals 6 squared is 36. Now I have a basic linear equation to solve. I can subtract 1, giving me 5x equals 35. I can divide by 5, giving me x equals 7. I can check my solution by plugging it back in. I do not always have to check my solutions. There will be a specific time that I talk about in example 3 where you have to check your solution. Here I don't have to, but if I wanted to, I could. To kind of save time on the video, I won't, but the way it would be done once again is just to plug it back into the original equation for x. Looking at example 2. So first thing I'm going to do is I'm going to isolate the radical part. If it makes you more comfortable, go ahead and change this to a radical expression. This is 2 times the cube root of x minus 2 squared equals 50. Notice that even though I have a radical and an exponent, since they're not the same, they do not cancel out. So I need to isolate my radical. So to get my radical by itself, I have to divide by 2, giving me the cube root of x minus 2 squared equals 25. So now that I have the radical by itself, now I have to raise each side to an exponent or to a power. I want to choose a power that is going to cancel my radical. So since my index is 3, I'm going to raise the left side to the 3rd power, which means I also have to raise the right side to the 3rd power. They're going to cancel on the left, and I get x minus 2 squared equals 25 cubed, which is going to be a huge number. I'm going to leave it as 25 cubed right now, and I'm going to show you why in a moment. So now I can try to solve the left side here. So I have a couple options here. I could FOIL this out, cube this out, and try to use the quadratic equation. Or I know that in order to get rid of a square, I just need to take a square root. So I'm going to go ahead and take the square root of each side. So now the square and the square root cancel, leaving me with x minus 2, and I don't need the parentheses. So now over here, this is the same thing as 25 to the 3 over 2. So remember when we talked about this earlier, if I want to simplify this, I can take the root first or I can cube it first. I can do either or. So because I know off the top of my head what the square root of 25 is, that is easier than figuring out what 25 cubed is. So I'm going to say this is x minus 2 equals taking the square root of 25, leaving the cube, 5 cubed. Well, I know 5 cubed is 125. Even if I didn't know that, that is much easier to figure out than 25 cubed. I can add 2 to both sides, and I get x equals 127. Again, I could check this by taking this number, this 125, plugging it in for x, 125 minus 2, square that, cube root it, multiply it by 2, I should get 50. I do not have to check it on this one. Looking at example 3, you'll see when we do have to check it. So remember extraneous solutions, we've talked about these before. This is when you plug in a number that you get for a solution and it doesn't work. So numbers that occur as a solution but do not work when plugged back in. So, numbers that occur as a solution but do not work when they get plugged back in. Extraneous solutions can occur when a variable is raised to a power. So if you look back in those previous examples, I never raised my variable to a power. All I did. So again, extraneous solutions occur when a variable is raised to a power. So if I look at example 3, I still want to isolate the variable, or excuse me, isolate the radical. Even though there's an x on both sides, I still follow those same steps because this is a radical equation. Equal sign, variable under the radical. So isolating the radical, I'm going to have to add 3 to each side, giving me the square root of x plus 2 equals 2x plus 3. Still following the same rules. I'm not going to let it throw me off the fact that I have an x on both sides. So from here, I want to get the radical gone. So in order to get rid of a square root, remember that it's an index of 2 if it's not written. I'm going to square both sides. So when I square the left, those will cancel. I have to square the whole right side, so I show that with parentheses. So when I square the square root of x plus 2, those cancel, giving me x plus 2. On the right-hand side, okay. On the right-hand side, when I square 2x plus 3, remember I can only distribute a square if it's multiplication. Because I'm adding in the middle here, I have to write this twice and FOIL, giving me 2x plus 3 times 2x plus 3. So now I have to work this out. So I get x plus 2 equals 4x squared plus 6x plus 6x plus 9. Cleaning this up, I get x plus 2 equals 4x squared plus 12x plus 9. From here, I notice that this is a quadratic equation. Because it is quadratic, think back to what we did in the previous unit. Remember math, things don't go away. Because it's quadratic, I have to get it equal to 0, and then I can either use square roots, I can factor, or I can use the quadratic formula. So, I am going to go ahead and subtract an x and subtract a 2, and I get 0 equals 4x squared. When I subtracted x, I was left with 11x. When I subtracted 2, I was left with positive 7. I don't want to try to factor this, so I'm going to go ahead and use the quadratic formula. So using the quadratic formula, I get x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Well, that gives me negative 11 plus or minus the square root of 121 minus 112 all over 8. And that reduces to negative 11 plus or minus the square root of 9 all over 8. Remember, in math, if we can do the math, we do it. So that gives me, I'm going to run it over here, negative 11 plus or minus 3 over 8. Well, negative 11 plus 3 gives me negative 8 over 8, which gives me negative 1. Negative 11 minus 3 gives me negative 14 over 8, which reduces to negative 7 over 4. Now, I'm going to come way back up here. And remember I said that extraneous solutions occur when a variable is raised to a power. I raised a variable to a power. I raised an expression involving a variable to a power. So I'm going to have to check to make sure both of my solutions actually work and that neither of them are extraneous. So I'm going to roll back down here. I'm going to rewrite my original problem out because you can't see it. I can't keep them both on the same screen. So my original problem was the square root of x plus 2 minus 3 equals 2x. So I'm going to start by plugging my negative 1 in. When I plug negative 1 in, I end up with negative 1 plus 2 minus 3 equals 2 times negative 1, which gives me the square root of 1 minus 3 equals negative 2. Well, 1 minus 3 equals negative 2. That's true, so this is a solution. I also have to check negative 7 over 4. So now I'm going to plug negative 7 over 4 in, giving me the square root of negative 7 over 4 plus 2. I'm anticipating that in order to add those, I'm going to need a common denominator. So right away, I'm going to go ahead and say 2 over 1 times 4 is 8 over 4. So I'm going to write 2 as 8 over 4. Minus 3 equals 2 times negative 7 over 4. Well, that leaves me the square root of 1/4 under the radical minus 3. I want to know, does it equal negative 14 over 4? Well, the square root of 1/4, I know the square root of 1 is 1. I know the square root of 4 is 2. So therefore, the square root of 1/4 is 1/2 minus 3. Does that equal negative 14 over 4 or negative 7/2? Well, 1/2 minus 3, so I need a common denominator, so I'm going to multiply 3 over 1 by 2, and I get 1/2 minus 6 over 2. Does that equal negative 7/2? Well, 1 minus 6 is negative 5. Since negative 5 over 2 does not equal negative 7 over 2, this would be considered an extraneous solution. So even though I got it as an answer up here, it did not work when I checked it, so it is extraneous. And negative 1 is my only solution, so it'll be the only one I circle.